Biosort presents Ifarm, Individualized Aquaculture. Advancing from group-based farming to an individualized approach is revolutionary in salmon farming. Ifarm consists of a custom cage top, a V-shaped passage to the surface, and an Ifarm sensor. Salmon naturally swim through the Ifarm sensor as they rise to the surface in order to fill their swim bladders. The salmon then return below the cage top to feed. The Ifarm sensor scans each fish and uses automatic image processing to uniquely identify each individual. Precise weight and growth are measured for each fish. Ifarm measures welfare indicators such as condition factor, injuries and deformities. A number of symptoms are recognized, including loser fish, winter ulcer, discoloration and other external symptoms. Sea lice are counted on the entire fish. The operator can tell the system to sort individual fish to customized treatment. Sorting and treatment of only the selected salmon is a revolution compared to current group-based treatment. The fish can be moved gently for the treatment of individual fish, a group of fish, or the entire site. The result is less stress, injury and disease, and a better appetite. An interactive feeding model improves the feed conversion ratio. Ifarm can sort fish by weight and size. Fish above 5 kilograms can be sorted to a separate cage for processing. A warning system detects if fish are missing and makes immediate action possible. Fish with lice can be sorted out. And treatment is only applied to fish that do have lice. The custom top also keeps the fish at a depth with very few lice. Ifarm generates reports for all desired data. Ifarm advances cage-based farming to a new level, improves fish health and welfare, and strengthens Norway's advantage as salmon producer.
Solar-powered floating farms could help feed the world. Barcelona-based company Forward Thinking Architecture has developed a solar-powered floating farm system that could ease growing global food demand. Smart Floating Farms, or SFF, was inspired by traditional grid-shaped fish farms in Asia. Each SFF is 200 meters wide and 350 meters long, roughly the size of 6 football fields. They can be connected to form a cluster of modules. Photovoltaic panels are installed on the top level to harvest sunlight for electricity, and it has rainwater collectors for irrigation purposes. Other renewable energy technologies such as micro-wind turbines may also be added. The second level is a greenhouse for the vegetables, which are grown without soil under the hydroponic system. The plants receive natural light from the skylight opening. The ground level is used as a fish farm on the open sea and features a fish egg hatchery, a slaughterhouse and a storage room for the fish. By using farms in nearby waters as a food source, the SFF can help reduce reliance on imported food. All the modules are centrally controlled by software via cloud technology. The production data will be analyzed and can be used to make comparisons on the food needs for specific cities. Each SFF is estimated to have a maximum production of just over 8 tons of vegetables and slightly over 1.7 tons of fish per year. The floating farms are ideal for densely populated cities near coastal areas, such as Los Angeles, New York, Tokyo, Singapore, and Hong Kong. As the world's population increases, food demand is expected to increase 50% by 2030 and 70% by 2050.
Chronic labor shortages make it difficult for livestock farmers to monitor their herds as carefully as they should. UMotion collects cattle data using wearable IoT devices fitted with multiple sensors. The data is sent to a receiver in the cattle shed, which uploads it to a server for analysis. The results of this analysis, based on past data and specialist expertise, are sent to the farmer as visual feedback in the form of graphs and charts. Combining data collected by IoT devices with on-site human observations and specialist expertise, UMotion improves cattle management accuracy. Transforming agriculture through AI and IoT. NTT Technocross.